Alright, welcome back. So we're on Unit 5. You just finished working with parallel and perpendicular lines, and now we're going to use some of those properties when we go into quadrilaterals. Now, any shape that has four sides is generally referred to as a quadrilateral. The specific ones you know, and I bet you could name at least 4 or 5 of them. Those are special types of quadrilaterals. Now, any shape with 4 sides is just referred to as quadrilateral. It doesn't have to be specific ones, but we're going to be looking at some specific ones, and they're going to be related, some of them, and I'm going to show you how when we get more of them going. So the ones we're going to look at is parallelogram, and these are not in any particular order. A rectangle, a rhombus, and square. And I'll show you how these are all interrelated and stuff later. Now there is a special one called the kite. And the last two we're going to refer to and look at is a trapezoid and isosceles trapezoid. So yes, that word isosceles comes back. And it means the same thing it did with triangles, but we're just going to do in 4-sided shapes. So we'll work on those later. So these all have the same property, that they have 4 sides and coincidentally 4 angles. But other characteristics that make them unique from each other. So the first one we're going to look at is the parallelogram. So I did list that first, but it doesn't mean we have to look at it first. Alright, so every parallelogram has 5 properties. Whether you're going to be asked to work with them or not, that's depending on the problem. So the 5 properties a parallelogram has, and so I'm going to list one in each one of these boxes so you can see them individually instead of all crowded into one. So if I put arrows on them, left and right are have the same arrow, and then top and bottom are the same arrow. So these come from opposite sides are parallel. So if we had a transversal going through here, we can make alternate interior angles, and then we can figure out different things with them. So with the arrows there, the top and bottom are parallel, and the left and right are parallel. So opposite sides are parallel. Maybe I should write both pairs. Both pairs of opposite sides are parallel. Now, as opposed to this one, so both pairs of opposite, I'm going to abbreviate opposite OPP, sides are also equal or congruent. So that's going to be kind of the same picture looking here, except for top and bottom are going to be the same measure or equal, and left and right are going to be the same measure or equal. So there's a lot of stuff already going on. Top and bottom, parallel and congruent. Left and right, parallel and congruent. So then we get to some other parts. So the angles, when you go across a figure, are equal to each other. So diagonally, they're congruent, and going the other way, those two are congruent. So both pairs or both sets of opposite angles are equal to each other or congruent. Alright, so we have sides, and now we have angles, and the last couple things, we have another property with angles. So if I take any pair, so taking that picture I had before, any pair of angles that are next to each other, any pair, so the left pair, the bottom pair, the right pair, the top pair, these are always going to equal 180 together. So this means consecutive angles are 180 degrees, or they're supplements. So if you know one of them, you can subtract to figure out another one from 180. So these bottom two, I don't want to circle all the pairs because it'll make it a little bit crowded in here, but it's also the top two and then the right two off, so it would make 180 because we can just plug in different ones. Now the last picture I have here is going to be going through the shape, so that, and going crisscross the other way. So these two, and I'm going to use different marks, so that one, I just noticed the one above it, and I want to have different marks here. So these two are equal. So the diagonal is split up into congruent parts. So the diagonals bisect or split each other. Alright, so both diagonals bisect each other. So they're both split up equally. So if the x was 5, the other x would be 5. It doesn't mean that the dots on there are 5 also. They have a different number, but they're going to be the same. And I'll show you that in another example. So those are the only 5 characteristics of a parallelogram. So I didn't want to do that in one shape because it would get kind of crazy. So taking that over to these examples. Alright, so here, so just determining from values what you have. So opposite angles are equal, so automatically one number can transfer to the other one, so that's 125. So that's 125. So, and then any pair next to each other is going to equal 180. So if I do 180 minus 125, that comes up with 55. So the other two would be 55, and and that would just transfer over to the other one if I was looking for the other one. I'm just going to go to the one below because you can see it right now. Now these deal with the sides here. So the angles I had across from each other were equal, and now the sides I have are across from each other are equal as well. So I have what? 5y minus 3 is equal to 12. So top and bottom are equal. Solve for y. And then left and right are the same. So I would set 5 equal to 2x minus 1, or switch it if you like the x on the other side. 2x plus 1, plus 1 equals 5. So this last one up here, this example, there's some stuff written up here. This means that this part is 3x minus 1, and this part is 4y plus 4. Alright, this is going back to that last property. The diagonals are equal to each other, so this one is equal to this part. So on one part, and then going the other way, they're equal. So 16 equals 4y plus 4. And all this is asking you to do is solve for x and solve for y. Alright, so if you have questions, let me know. The problems down below, those are your homework for tonight. And turn it in when you get it done. Thanks, bye.